So now that we've developed an understanding of a trigonometric angle, that's one that starts with a vertex at the origin, an initial ray on the x-axis, and a terminal ray that is measured or that rotates around the Cartesian plane, that we can evaluate the measure of any given angle, we like to call theta, in either degrees or in radians. Well, there are some cool things that we can start to look at now that we have this type of angle. And the first of which is we can start to look at finding a way to describe this distance as actual distance, real world distance, feet, inches, miles, etc. So theta is a measure of magnitude. It tells how far around the terminal ray has traveled through 360 degrees or 2 pi radians, but it doesn't tell us that much about actual distance in the real world. But if we were to have a dot on our terminal ray, we can imagine that that dot would have started, say, here, and as the terminal side moves around the origin, that dot would sort of trace out a circle. Let's put one on to show, like this. So you can imagine if this side, if I continued to move the terminal side around the origin, this dot would trace out a circle. So we have a way to describe the distance that that dot has traveled, and we have a simple formula. That's the distance, arc length. By the way, this distance is called the arc length, which makes sense because this is an arc and we're measuring the length of it. Arc length is measured using the variable s, and the distance that that dot has traveled is equal to theta times the radius of the circle that's been carved out. And that this formula only holds true if theta is measured in radians. So if you start with degrees, you have to convert it to radians, then calculate. Or if you start with radians and want degrees, you can make the calculation and then convert to degrees. So that's the first cool thing that happens. The second is to notice that if I've traced out a circle or a part of a circle, right? I've traced an arc. At the same time, I will have traced a sector, this area between the angle or the origin and the arc. So this sector, or the area of the sector, can be calculated using the formula area equals 1/2 r squared, same radius, times theta, same theta, and this also has to be calculated in radians. Let's play around with the formulas. Let's start with arc length. So we're going to start with S equals theta times r. When we're given the information, pi over 3 for theta, and the radius of the circle is 4. So pi over 3 is in radians, so I can just calculate directly. Pi over 3 times 4 equals 4 pi over 3. And since we're talking about distance, and as human beings, we don't tend to talk about distance. How far did you drive to Seward? I drove 4 pi over 3 radians. That's crazy. We want to actually figure it out in inches because this information was in inches. So we have to do a calculation. And if I just plug this into my calculator, 4 times pi, 3.14, divided by 3, I get that it's approximately equal to 4.2 inches. So let's do one that starts with degrees. I want to know for a circle with a radius of 7 centimeters and an angle of 125 degrees, how long has, or what's the distance of the arc length. So in this case, I'm in degrees, so I have to convert to radians. 125 degrees times 180 degrees over pi radians. Well, that's 25/36 times pi radians. And now I can calculate using 25/36. So the length of the arc is theta 25 pi over 36 times 7. And that's 175 over 36 pi. And I don't want to do that by hand, so let's take 175 divided by 36 and multiply that by 3.14. And so it's 15.26. So we're looking at approximately 15.3 centimeters. So let's do a couple of sector areas and then we'll call it a day. If I'm looking at a circle with a radius of 5 meters and a sector defined by theta equal to 3 pi over 4, what's the area of that sector? So the area of the sector is 1/2 times the radius squared, so that's 25, times theta in radians, and I'm already in radians. 3 pi over 4. So clean it up a little bit. That's 75 pi over 8. 75 divided by 8 times 3.14. It's approximately 0.4 meters. And of course, meters are squared because we're talking about area. All right, this time let's do one that starts in degrees. Another circle. Radius is 8 feet. And the angle is 60 degrees. We want the area again. So first I have to convert 60 degrees to radians. Well, 60 divided by 180 is pi over 3 radians. And so the area is 1/2 times 8 squared times pi over 3. So that's 32 pi over 3. So it's approximately 33.5 square feet.